Hello everyone and welcome to this webinar. My name is Michael Evangelista and I will be your moderator for today. Just a few reminders that you are in listen-only mode to avoid unnecessary background noise. However, you can type in your questions anytime in the chat box and those questions will be answered by our panelists in the Q&A segment. The recording and certificate of this webinar will be sent out to you in 2 days' time. And our topic for today is about the medium voltage circuit breaker testing, and it will be presented by our very own Sumedi from Indonesia. So without any further ado, let me give you to Sumedi. Zoom.
Okay, Michael, thank you very much for your introduction. Okay, good morning, good afternoon, everyone, wherever you are. Yeah, let me introduce myself once again. My name is Jumaidi. I am as an application engineer based in Indonesia, and I have been joined Megger almost 9 years, and taking the circuit breaker product is, I think, around 5 years ago. Yeah, I hope we can discuss on today regarding to the medium voltage circuit breaker. Yeah, you can type your question in the chat box. Yeah, the topic today is about the medium voltage circuit breaker testing. If you have seen before my webinar talking about the circuit breaker testing in general, so maybe you can see the same information before, just for overview on today's webinar. But today webinar will be talk more detail about the testing that should be done on the medium voltage circuit breaker, cover to the basic testing and also additional testing. So I hope I can give you good information and add your knowledge about the testing on the MV circuit breaker. Okay, this is the agenda today. I will talk about the medium voltage switchgear, just overview, and explain about the breaker itself, classification breaker on MVCB, medium voltage circuit breaker, and talking and give you information about the international standard for MV circuit breaker test and definition on the MV circuit breaker. Also, how does breaker work, and the main topic, basic tests on MV circuit breaker and additional tests will be talk after that. And at the end, I will talk, give you information summaries of this webinar. And at the end, again, we will inform you the major solution regarding to the all testing that we will talk today. Okay, let's move to the next slide. I will give you overview a little bit about the medium voltage switchgear. This is the sample of the air insulated switchgear, or AIS, very common. You can see on the MV switchgear, mostly in distribution level voltage. Yeah, because why I need to talk this, before I talk about the circuit breaker and all testing of the MV breaker, let me introduce this again. So here you will understand where is the location of the breaker itself on the MV switchgear. Because in the electric power system, switchgear is combination of electrical, like a breaker, switch, or fuse to protect and isolate the electrical equipment. So if you see here, most of the switchgear include the circuit breaker, current transformer, a VT or voltage transformer, protection relay, measuring instrument like meter, Kelvin meter, an electrical switch, electrical fuse, MCCB, lightning arrestor or surge arrestor, maybe on the XP switchgear. Electrical isolator and other associated equipment will be put in the one switchgear panel. And for medium voltage switchgear, typically you can find some component like picture here. So there are some component in the MV switchgear. Number one, if you can see here, this is the location of the circuit breaker mostly in the middle part of the panel. And number two, this is the secondary side panel, consists some like a relay, a metering, or anything based on the secondary side will be put in this location. Number three is enclosure to put the all component. Number four, if you see in bottom part of the panel, mostly they put the VT, voltage transformer, or sensor and fuse. So mostly they put in bottom part of the panel. And for the number five, the current transformer or CT position, mostly you can see close to the bus bar in the cable, around the cable that connect to bus bar or bus bar. Yeah, some panel, some MV switchgear, they put the CT maybe close to the VT, but in general all MV switchgear will consist these components: relay, metering, VT, CT, and also breaker. So the breaker is the big part of the MV switchgear. So this is why we need to test this part, the breaker, on the maintenance time. Okay. Other type also you can see here. They have the right back out type. So it's almost the same, but normally how to take out the breaker itself, you need the additional tool. Okay, now go to the explanation about the MV circuit breaker. Yeah, actually the definition circuit breaker based on IC will be the same for the MV or XP. So medium voltage circuit breaker is an automatically electrical device designed to protect an electrical circuit from damage caused by overload or short circuit. Yeah. So in other words, CB or circuit breaker is electrical switch that designed to protect system from damage condition where it's caused by excess current like overload or short circuit. This is the definition of the MV circuit breaker. So the basic function of the breaker is to interrupt current flow after fault is detected by other component, like on this case from the relay, and then the breaker can do action to interrupt the fault. Not like fuse, breaker can be operated many times because as we know the fuse only one time after break you need to replace the fuse, but the breaker you can operate many times because they have the separate control circuit to operate the breaker. Now this is the MV breaker based on the ANSI rating. There are three conditions based on the voltage level, primary carrying current, and fault breaking current. So on the based on the voltage level, there are maybe 5 kV, 8 kV breaker, 15 kV, 27, and 38, maybe more. Maybe in other case you can find the other voltage level. And also primary carrying current. There are 1200 m, 2000 m, 3000 m, 4000 m, maybe more than 4000 m you can find in your country, but mostly maximum for 4000 m in the many application. The primary current is actually the maximum current can flow to the breaker continuously. So usually the design engineer they choose the breaker based on this primary carrying current and voltage level, and after they calculate everything they can define this type. And based on the fault breaking current, there are 16 kilo 20 kilo 25 kilo up to maybe 75 kilo you can find in the market. So the fault breaking current actually is the current that breaker is able to interrupt without being destroy the or causing an electrical arc with unacceptable duration. Mostly they have the limit time. For an example, they have the 3-second for breaking current or 2-second for breaking current. So if you see the 16 kilo amp, 3-second means the maximum the breaker can get the high current only 3 seconds. Otherwise, the breaker will broken. Okay, just a moment. Okay, now we can continue to the next slide. This just yeah. If you're talking about the medium voltage circuit breaker, of course, we need to know the classification breaker based on the voltage level. There are 3 types based on the voltage: low voltage circuit breaker, medium voltage circuit breaker that we want to talk to today, and the last one is high voltage circuit breaker. LV or low voltage circuit breaker for the voltage less than 1 kV, normally we consider as the LV breaker. And for medium voltage, there are many literature talking about this. Some literature they set 1 kV but up to 52 kV, and others literature maybe you can find up to 72 kV. But mostly in the world so far, I just find maybe up to 36 kV for the medium voltage. But actually more than 36 also considered as the medium voltage circuit breaker. And above the medium voltage level, we consider as high voltage circuit breaker. Actually, we have one more extra high voltage, maybe like the system in the 500 kV or maybe 1 megavolt. I think some operator or user define as the extra high voltage. So now we know the level of the medium voltage breaker. So we will talk more detail about this breaker. Okay, now how does it work? Yeah, actually the almost all breaker has the same principle. The circuit breaker use a mechanical means to separate two contact in arc quenching medium to interrupt the flow of electricity. So the arc quenching medium of the breaker is using different technology. There are several different types like a vacuum interrupter, SF6 interrupter, or air magnetic, maybe, and also air or anything using for arc quenching. It can affect to the type of the breaker. And based on the mechanism, there are 2 types for the MV breaker. Actually, we have more, but on the MV breaker, mostly spring and magnetic type for the mechanism. Yeah, this is the circuit breaker class based on the technology. There are air or gas circuit breaker and vacuum circuit breaker, and the last one is oil circuit breaker. For air or gas circuit breaker is there are 3 types: ACB, air and or air blast, and SF6 as using this medium to extinguish the arch when the breaker operates. And for vacuum, actually this vacuum breaker technology introduced in I think 1960, a long time ago, but still exists until now with the new development. So actually the vacuum circuit breaker is a circuit breaker where the arcing quenching takes place in vacuum. They use the vacuum medium to extinguish the arcing between contact inside the breaker. And oil, they use the oil to extinguish the arcing inside the breaker. There are 2 types, bulk oil and minimum oil. Whereas the minimum oil is they use the minimum oil to extinguish the arching, and mostly this type breaker is very fast, operating time very fast compared to the bulk oil. And you can see more detail of this type of breaker on my previous webinar to explain about this. Okay, this is now we move to the some standards to be used for circuit breaker test. The common the famous standard is IEEE C37.4/1999. This is the IEEE standard rating structure for AC high voltage circuit breaker. So on this standard, you can see some testing procedure and some criteria to define the breaker good condition or need investigation based on the certain testing. And the other famous standard is IC or IEEE 6227/1. This is the high voltage circuit breaker and control gear. This is also, you can see the testing procedure, criteria, and definition of any description on the breaker. And the ANSI or any TA also can be used for your reference regarding to the circuit breaker test to define like minimum voltage to be used for testing, like a hipot or contact resistance value. So you can see on this ANSI-NITA standard, and still many more standard can be used for your reference. Okay, now why we need to do maintenance on the medium voltage circuit breaker? The circuit breaker is intended to switch on and off electric current on the distribution network for routine operation and protection of other equipment. So electric transmission system failure and equipment destruction can occur if the circuit breaker fails to operate because of lack of preventive maintenance. So if you don't do good maintenance, maybe you will find some issue like this. Because the main purpose why we need to test is to verify the breaker performance, to check the circuit breaker is operating properly, and to prevent outgates that lead to lost income. So this is the end of the goal. We don't want the loss of income because our system shut down caused by breaker failure. And also we need to verify the breaker adjustment or within specification. After you buy breaker, mostly you need to test to make sure the breaker specification is based on your requirement. And data is available to better evaluate in the condition of the breaker. So if you test the breaker at the beginning, at least you have the data can be used to analyze if you have problem in the future. So data is very important for the maintenance guy to analyze condition of your asset and provide protection for expensive equipment. I believe the breaker itself, not the price of breaker will be less compared to the all component in your system. But if the breaker fail, automatically you will lose all component. You will lose your money because your system broken, and then this is why the maintenance of breaker very important. Provide protection for expensive equipment that you have in your system. Yeah, this is the information maybe can be used to consider why we don't do maintenance to your breaker. Because based on the SIGRE research 2012, for the common fault, they have specified based on this information does not close on command. This higher percentage, 28.2%, and followed by lock open or close position. It can be because the mechanical issue, but it gives a big percentage. Number two, I think 25.1%, and does not open on command, breakdown, pull and ground, operate without command, and other. So actually, this reset it takes from medium voltage breaker and also high voltage circuit breaker. So I think some information is very relevant to the MV circuit breaker, like does not close on command, and also operate without command, mostly because get trigger from external, like maybe suddenly a relay work, give trigger to the breaker and then breaker operate, or does not open and command. So three of these common fault I think relevant to the MV circuit breaker. And for on component, operating mechanism give you high percentage, 70% compared to other like insulation or interrupter fault. So based on this information, I think we need to do breaker maintenance, MV breaker maintenance correctly. Yeah. Okay, now we'll go to the main topic, the electrical testing for medium voltage circuit breaker. There are many testing to be done actually, but there are two types, basic test or an additional test. You can find this testing on this some standard, but mostly these four basic tests you can find in all international standard, like insulation resistance test, contact resistance test, breaker timing test, and also over potential. I mean, it is the hipot testing. Mostly the service company, they do this testing as basic test, and normally also they provide you or ask you for additional testing like vacuum battle interrupter integrated test, time travel analysis, almost the same with the breaker timing but more detail. Regarding to detect the mechanical issue, as you know from previous slide, the mechanical component is give high percentage. This is why time travel analysis is very important to be tested on the MV circuit breaker. Minimum trip voltage test, operating coil current, spring charge motor test, and also some operator they do power factor testing. But I think on the medium voltage very rarely. So normally only up to number 9, spring charge motor test. Now I will try to explain one test by one test, so you can define later on which one is very important for your system. Okay, first test is insulation resistance test. This test actually not mentioned in the any standard regarding to circuit breaker test, but if you see the insulation resistance test in general, normally we need to test all electrical components to test the insulation resistance first before you continue to other tests. Yeah, as you know, the design of the insulation system for metal enclosed switchgear based upon life expectancy of the about maybe around more than 30 years. However, environmental conditions such as like a dirt, moisture, and corrosive atmosphere can reduce the lifetime of the insulation. Especially moisture combined with dirt is greatest deterioration factor for insulation system because of leaking and cracking, which will result eventual failure. So why this is very important to test at the first test before you do other testing. You need to test the insulation resistance to make sure there is no high leakage current to the between insulator. So actually there are two methods for testing insulation resistance, 2-wire or 3-wire method. Whereas the 2-wire is common test. You just need to cable. We inject a DC high voltage to the object to be tested, and then you measure the leakage current. And equipment test can calculate based on ohm law to get the resistance mega ohm value. Usually this test using 2500 volt or 5 kV volt DC, depending on the class of the breaker. You can see the standard value to test this application on the like the NC NETA table 100.1. There is information about the how much the voltage level to be injected to the breaker based on the class breaker. And also you can find in our mega literature, you can find a complete guide to electrical insulation testing. On page 57, you can see the procedure how to test the breaker, and also information about the voltage level depending on the circuit breaker class. Yeah, this is the table based on the NC NETA, where you can see the minimum test voltage. If you have the system 15 kV, you need to test at least with the 2.5 kV enough to verify problem on insulation on the 15 kV circuit breaker, and you need to get the 5,000 mega ohm. This is if only refer to this standard, but actually to analyze the insulation resistance, mostly the best way is trending analysis. You need to trend time by time. If you see something change, maybe suddenly insulation going down, even though still over the limit, but you need to be careful because when your insulation already get deterioration. And this is the connection diagram. For connection diagram, actually, you also can see this connection on some standard, but we do in two ways: when breaker open, and also when breaker actually this is and close. Close and open. When breaker close, normally you test like this: you inject voltage to the one pole in the one phase, and other two phase you can short to the ground, and then you can do on the other phase Y with the same condition. You short air and blue to the ground. If you test phase blue, you need to short red and yellow to the ground. So this is the wiring connection for the when the CB close. When CB open, you can follow like this. You can sort each pole red, yellow, blue in the phase part and the return part. Where is the return part? You need to connect to the ground. So this is the wiring connection of the insulation resistance test of the breaker. Next, the contact resistance test. This is also important to be tested on the circuit breaker because the contact resistance test is very important for contact that carry large amount of current, like a circuit breaker. As higher contact resistance leads to higher losses. So if higher resistance, and you will get the higher losses. Lower current carrying capacity and dangerous hotspot in substation. So if you have higher resistance, you get the higher losses. So will impact to the heating on the connection on the main contact. So if you have this long time, will reduce lifetime of the breaker. And also corrosion. To make sure there is no corrosion on the main contact, you need to test this contact resistance test because this test can reduce some corrosion between contact inside the breaker. So there are two standards to testing circuit breaker for the contact corrosion test. IC 69694 state minimum 50 m, and other standard like NC, they state minimum 100 m. So actually for testing contact resistance, we can do with 1 m, maybe 10 m. In principle, it will be the same. You can test with the lower current, but for the circuit breaker, if you follow the standard, should be using high current. But please remember, not more than rate current of the circuit breaker. Yeah, the reason why high current is needed for testing the circuit breaker, there are some reasons. The first is noise ratio and induced current. The second one is contamination, and the last one is hotspot effect. Whereas these three components can be eliminated when you use the high current. Okay, for detailed information about this, you can see my webinar about the practical of the contact corrosion test. There is explanation more detail about this, but in generally, these three part can give effect to the contact resistance measurement, and to eliminate these three components, you need to use high current. Okay, this is the reason. And how to interpret the result? This is the interpretation. The best way is you need to follow manufacturer published data. I believe the manufacturer breaker can give you information about this value, the minimum and maximum contact resistance value. And also, if you don't have this information, maybe you have the old type breaker, whereas you don't, you lost the manufacturer published data or manual book of the breaker. So maybe you can follow this standard ANSI or NITA ITS 2009 section 762 part 3 and 2. The state micro ohm or DC millivolt drop values shall not exceed the high level of the normal range as indicated in the manufacturer's published data. If manufacturer published data is not available, investigate value that deviate from adjacent poles or similar breakers by more than 50% of the lowest value. So still, they recommend to use the manufacturer published data, but if it is not available, you can use this criteria, 50% of the lowest value. And other standard like IEEE C37, the state should be less than 200% of the maximum value given by manufacturer. But still, the standard you need the reference value from manufacturer. And then you can estimate as long as the value less than 200% means the contact is still fine, still okay. But the goal is you need to make sure the contact resistance is lower as possible. Next test, breaker timing test. Breaker timing test is also part of the basic test. We need to test this to verify the operating time of the breaker to avoid the condition become a voltage divider when breaker is operated, especially for breaker has two interrupter per phase. So most standard they state the difference between three phase should less than 2 milliseconds. So you need to verify your breaker is follow that standard. Otherwise, it can make the systems not work properly. Yeah, this is the explanation of the timing test. You can see the IC 56 3.105.32. There is definition about its operating, like what does mean of opening time, closing time, open close, close open time. So you can read here clearly. So like the opening time is interval of time between the instant of energizing the opening release. So when the coil get the voltage at first time, and then up to when the arching contact have separate in all poles. So up to the all arching contact separated. So if you have only one separate, so the last time will be used as the opening time. So from here very clearly the opening time calculate based on the when the coil energized up to the arching contact separate, same as the closing time but opposite definition. And this is also an explanation about the open close time. So all these operations should be tested normally for the breaker timing test. So there are 5 operations: open, close, close, open, and open, close, open. Yeah, basically this is the principle of operation. The measuring process employ a principle known as the time pulse method. This allows counting of pulses of a regular frequency in time intervals. And then the software in the unit, in the equipment tester, in the microcontroller allows counting the pulses initiated by external signal obtained from the breaker's drive system. And then signal corresponding to the opening or closing of its contact of the breaker close the time gate. As soon as the signal for the contact closer appears, the microcontroller on the unit copies the content of the contour into its memory. So the number of pulses the microcontroller count is proportional to the interval elapsed from the moment of the trigger to the moment of closing. So basically, in general, basically this testing is measure the how long the changing of the resistance. If you see the breaker when breaker close and open, there is a changing on the resistance value on the certain limit, the close and open. So this equipment actually they want to measure how long the changing process from uh, A value to the B value, because when open and closed, the resistance of the circuit will be changed. Because the change very fast, you need to microcontroller and high speed timer also. So this is why you need to special equipment to do this testing. We call it the breaker timing test. How do we test it? You can see this is the example connection based on the our Megger product Agile, but actually all equipment not only from Megger will be provide the same connection, maybe only different on the return cable. You need to connect directly to the main contact. From the timing measurement, you need to connect to the main contact, red, yellow, blue, and other equipment you need to connect separately for the return cable. But for Agile, we just need connect once to the one of the return contact, and then you need to sort all the pull on the return contact. After that, after you connect to the main contact, you need to do connection to the control circuit, to the coil, to trigger the breaker operate. And then you do open, close, and close, open operation. You get the timing, and you can calculate the delta time between phase, or I believe all equipment tester for testing this purpose will provide you the delta or different time between 3 phase, because the main goal is we want to know the difference between all three phase. This example how do we connect to the coil. This is the example of the single line diagram of the circuit breaker. Actually, to the control circuit, we need to connect at least 3 terminal, and some equipment you need to connect 4 terminal. You need to find the positive terminal, negative terminal, and closed terminal and open coil terminal. So like this, you can see this is the closing coil, and this is tripping coil. Closing coil on the system, you need to find the on the terminal block number 7. If you put our connection, this one to the closing coil TB17 and TB18 for the opening coil, and then positive to any positive point on the circuit. On this case, I just put here on the TB11 and TB12 for the negative point if needed. Like the AGL, we don't need to connect the negative point because we use from the system. So we only need the 3 connection to control circuit. So again, only 2 connection, one to main contact and the second one to the coil circuit. And interpretation, there are many standard, but mostly we use the IC 62271-100. If you don't have the information from the manufacturer of CB, but mostly you will find on datasheet. You can find on the website or on the datasheet of the breaker. Usually they will provide those information. Like an example, this is one type of the breaker. They put the opening time on the datasheet. They put opening time and closing time, how much the minimum value and how much the maximum value. So if you know this, you can verify your test result is still good or need verify, not investigated. If you don't have this information from circuit breaker manufacturer, maybe you can to follow this standard. Where is the for closed operation, a fourth cycle, if 50 hertz mean 20 millisecond divided 4, 5 millisecond maximum different for closed operation, and for open operation 3.3 millisecond. If you have different more than this specification, you need to do investigation. And in example for the test result from our product, you can see open time, different ABC, and also profile curve, red, yellow, blue, like this. And this is the sum CB diagnosis based on timing. You can see here what happened, what to be checked if you have the faster close, slower close, and open time normal. And so from this table, you can learn to investigate the problem. DC hipot also considered as the basic test. Actually, this test to check the insulation performance of your breaker, same like the insulation resistance test, but this is more specific, more confident with when you test this hipot test. Whereas there are 2 types of the hipot, DC and AC. AC is still preferred, and DC only can be done if you don't have the AC hipot. But if the better way is IC for testing the hipot. Whereas the maintenance test policy should be 75% of final factory test. You need to do in open and close position. This is some information regarding to the time duration and rate operating voltage if you use the DC or AC hipot. Some OEM breaker as I know, sometimes they test more than 1 minute. They test 15 minutes to see the the capability of the breaker still okay with the certain voltage level. And this is the connection, same like insulation resistance test, but be careful. This testing only, especially AC test, only can be done after you get the pass value on the insulation resistance test. If you get fail, it's not recommended to test this hipot on the breaker. So after you get the pass indication, pass value from the insulation test, and then you can continue to this test. And this is acceptance criteria. Yeah, actually there is no detailed information about how much the leakage current to be accepted, good condition or bad, because the most of the standard they just inform as long as no disruptive discharge occur nor over when you do the hypothesis, mean the breaker is okay. So, but I know some OEM they have standard maybe 5 milliamp or other maybe 0.5 milliamp. Actually, 0.5 milliamp regarding to the safety safety to the human body. So because we can withstand up to 0.5 milliamp, but as I know, the milliamp value is not mentioned in any standard. They just state as long as no disruptive discharge, no flashover, so means the results are okay. Most OEM they use the minimum limit from the hypo tester to make sure this condition. Okay, next I continue to the additional test, especially for vacuum bottle breaker. Yeah, the purpose of vacuum integrity test is to confirm that the pressure in vacuum interrupter is low enough for the interrupter to reliably perform its switching and insulating function. So normally we need to test the pressure, measuring the pressure inside the vacuum interrupter. But the problem, because very difficult task and needs special equipment and actually on vacuum interrupter by itself, so you need to check only vacuum, not when installed in the CB. So because these difficulties, we can use the voltage Whiston test to verify vacuum pressure. So because has a relationship between vacuum pressure with the Whiston voltage test based on the Parson curve. You see, this is the Parson curve, where this is the relationship between voltage Whiston for vacuum bottle and the air pressure within the bottle. So because this low, we can use the second way to detect the pressure problem with the vacuum bottle test with the voltage Whiston test. And actually you can test with AC or DC, it doesn't matter. But the DC has advantage because the magnitude of the current is lower than the AC. So I mean with DC will be safety for testing the vacuum bottle. Yeah, even though actually DC and DC. This is why you can see for the vacuum bottle test, mostly all tester provide with DC output rather than the AC output. The reason is one, because the DC resistive current component is 100 to 1000 times lower in magnitude than the AC capacitive current component. So this is the reason why we most equipment tester they provide DC. And also just for your information to be careful, because if you talk about the vacuum circuit breaker or vacuum circuit bottle, if you test above for the above 35 kV, or AC or DC test will produce the X-rays. So this is also one consideration to choose the equipment tester to avoid the X-ray produced when you do testing, especially when 35 kV AC or DC. Mostly to minimize the risk of exposure to X-ray, personnel should stand at least 3 meters away from the vacuum interrupter being tested. And vacuum interrupter manufacturer, in compliance with applicable IC and ANSI standard, do not produce X-ray at nominal operating voltage. So as long as operate in the nominal operating voltage, all vacuum interrupter manufacturer comply with this standard, not produce X-ray effect. But the problem for testing vacuum, normally we need to inject higher voltage, maybe 2 times plus 1 kV. So this is why to be careful to choose the equipment tester. And our product, Fider, has been proved and has been tested on the OEM breaker that prove our equipment because complain not to produce this X-ray when we do testing. This is the connection, circuit connection, very simple connection. You can test pass by pass, 2 cable from the equipment test connect to each terminal of the breaker, vacuum breaker. So is the measurement of leakage current important? Just a moment. Sorry. Yeah. Some equipment they don't provide you the leakage current value because actually the leakage current value is not really important on the vacuum, because if you see already leakage, either 100 microamp, 200 microamp, or 300 microamp, still because the vacuum, we still consider the problem on the vacuum itself. But most of the equipment they state as long as less than 300 microamp, we can consider the vacuum bottle is still good. If you see the leakage current on this testing more than 300 microamp, so you need to do some investigation. So actually, yeah, this is why actually the value of the leak current not really important, because very get impact from many things. Too many things can be influence the leakage current. So we cannot use it as trending. Example, if you got 100 microamp and suddenly it can change to the 600 or maybe more than 300 microamp. This is why we cannot use the value on the leakage current on the vacuum bottle test as a reference. Okay, and the timing travel analysis. This is also additional testing that similar with the timing breaker timing test, but mostly to detect the mechanical problem on the breaker. On this testing, actually, we need to connect the specific accessories. We call it a transducer. You need to connect directly close as possible to the mechanical part of the breaker. There are 2 types, linear or rotary, depending how the breaker move. If you see the breaker, mechanic breaker moving in the cycle rotating, you can use the rotating or transducer. But if you see the moving of the mechanical breaker is linear, you can use the linear transducer. So that transducer can convert mechanical condition to the digital value. The goal of this test, actually, we need to define the total travel, like over travel, rebound, under travel, stroke, speed, and damping indication. What does mean? If you see this, if you do the travel and timing analysis, you can find this curve. This curve can give you information about the stroke. Stroke is the maximum distance from beginning to the end, from this one to this one. This is the stroke value. If you see there are many corrosion or maybe problem on the mechanical part, maybe the stroke value will be less if have many short circuit happen in the breaker. And also you can calculate the speed, how fast the breaker operate. And arching zone, you also can find the arching zone condition and damping zone if breaker has damping part. But the important thing for the medium voltage, I think the stroke value and speed. If you can measure it, then you will get more information about the mechanical issue of the breaker. This is the sample of the transducer, and generally all brand tester will provide you the same transducer. This is the rotary transducer, this is the linear transducer, depending on how much the length of the stroke inside the breaker, and this additional part to be used to connect our transducer. This is example how we install the transducer. This is the example the MV breaker, but I know this is in the training session. We can put the linear. If you see the bottom part of the breaker, this is the mechanical part. Sorry, the breaker here position when breaker open and close. There is a link can move up and down. You can see here this link will be moved up and down. From this part, you can connect our linear transducer. So if you see the breaker open and close, this transducer will move as same like the breaker up and down. This is how to install the linear transducer if you can connect to the breaker. But I know in the real condition it's not possible like this. Mostly on the MV breaker, we only possible to connect rotary transducer. Mostly in the close to the circuit breaker part, you can see the something rotate, and then you can install the rotating transducer, rotary transducer. This is the interpretation. This is the analysis test. So no standard info about the limit value. You can use the manufacturer published data as your reference, or commissioning test report for your reference. If you don't have all information, you can do test at the beginning on the good breaker with the same specification, and then you can use it as your reference. This example of the report from the commissioning from the OEM breaker. They provide this information: speed, stroke value, offer travel, how much the offer the travel when breaker operate, rebounds like the vibration on the mechanic part. So you will get this information from the OEM manufacturer, and this is the result example for the open close operation like this. Minimum trip voltage also important. This is considered as the additional testing. With this test, we want to define how much the voltage can operate the breaker, because as you know, the voltage of the coil has a relationship with the breaker timing operation. If you have the lower voltage, the breaker time operation will be longer than nominal voltage. So mostly all OEM manufacturer, OEM breaker, they put the minimum and maximum voltage level to get the range of the breaker time. It's very important, because if you can verify the minimum voltage of the coil, you can make sure your system should be not less than this requirement. Yeah, usually you just connect directly to the coil and adjust the voltage from maybe 70% to 100%. And for the standard, to interpret the result, you can use the IC 60694 edition 2, where is close, open, and close operation minimum 85% of rated operating voltage for AC or DC coil, and open 70% minimum. So as long as you have the breaker can operate with the 70%, means you have followed this standard. Operating current test, the next test also important because the coil current test also give you information about the problem on the coil armature, problem on the link, lower control voltage or bad wiring, short turn of coil winding. So from the coil current trace, you can define more specific where the problem come. So this is why the coil current can be measured on a routine test. Mostly you can see this test together with the breaker timing test. Yeah, how connection, you just put the clamp close as possible to the coil, and you can measure the current. If you can measure the tracer current, will be good because you can analyze more detail. Otherwise, you just get the maximum current. This example, two comparison between coil current before and after. So the first test and the second test give you information the different from the first peak and second peak. So if you have different coil current, give you different breaker timing operation, whereas the green curve give you longest timing compared to this purple curve. Yeah, we need to use the trending data to analyze this test. Spring charge motor test is, as I know, some OEM they put this test on the basic because they want to know the time, the charging process, because based on the standard C37, the maximum time should be less than 15 seconds. So you need to do adjustment if you will get the charging motor, spring charging motor, more than 15 seconds. Yeah, this is also important because you can define the problem on the motor. Otherwise, the breaker cannot operate because the motor cannot charge after close operation. This example from our equipment. You can see the current changing when the motor start operate. Current very high, and then going down and increase again up to the breaker motor is stopped. Okay, the summary of this test. You can see this table, which important tests to be done for the specific circuit breaker. For vacuum, 1 kV to 36 kV, the timing is the X1 green is applicable. Means you can test this, and X like this possible, and you can see the definition of this testing. But I recommend you at least you need to do basic testing on the MV circuit breaker. And if you have more tools, it will be good if you also can test the additional tests to make maintenance team confident to define the condition of the MV breaker. And this is the major solution. We have the insulation test. I think already know that we manufacture of the insulation test, major test. We have the MIT, depending on the voltage output. We have 5 up to 15 kV DC. In contact resistance, we have DLRO 200, 600 output, and also Milner with the good output, no ripple output, and also safety when you use in the high noise environment. And small unit, we have the MOM2, where it can provide up to 200 M for testing breaker and just go no go. You very lightest and good for application and medium voltage. Hipot we have up to 80 kV DC and certain kV for AC. And also we have the Agile and TM series, TM 1700 for testing breaker timing, whereas these two units can provide you also the coil current timing and also can be used for the travel analysis. Finder to test the vacuum integrity. We have this Finder unit that has been proved by OEM manufacturer. We don't produce the X-ray when testing with our equipment. B10E, this is for testing minimum voltage. So you can adjust the output voltage, this is your AC to the coil, closing coil or open coil to verify how much the minimum voltage can be operate the breaker. And also tracks, very good for testing some application like the circuit breaker timing. Minimum voltage also can be done as long as the high, not high burden, and contact resistance can be done also with this equipment. Yeah, at least 3 or 4 testing can be done with our tracks unit. Okay, that's all my presentation. I hope I give you useful information for your reference. Okay, Michael, I finished my presentation. I give you back.
Okay. Thank you so much, Sumedi, for that wonderful presentation, bro. And before going to the question and answer portion, I would like to remind everyone to fill up the survey when they close this webinar. There will be a pop-up survey form. Please fill it out for our improvements. Okay, so now we will have to answer the questions that we have here. One question is, do the test for medium voltage circuit breaker applicable to low voltage circuit breaker?
Okay, Michael. Yeah, actually, not all testing here applicable for LV circuit breaker. Yeah, maybe like insulation resistant, we can do it for on the LV circuit breaker and timing also. But usually we use different method for testing breaker timing on the LV compared to the MV. And hipot, usually we don't test this on the LV circuit breaker. And yeah, I can say in general, not many tests can be done for the LV. Only certain tests from the NV testing can be done for the LV. So not all can be applicable for the LV. Yeah.
Yes, correct, bro. Because the low voltage circuit breakers here, we are talking about the MCCBs or MCB. So for timing, and the applicable one is to do a current injection test because those breakers are thermal element. So the opening and closing shall be tested by primary current injection test. Right. So here another question here, bro. What will be the maximum time difference between poles?
I think he asked before I explained about the breaker timing test. Actually, if you see my slide, I will show again. You can follow this standard for different pool. Yeah, they can follow this standard. If you have system 50 hertz, mean there is 20 millisecond per cycle. So for the close operation, maximum 5 millisecond different between pool A, B, and C for close operation. But for open operation, should be less, around I think 20 divided 6, 3.3 millisecond is maximum limit for the open operation. different between pole. Actually, the last phase synchronizing between interrupter, actually this is for the high voltage circuit breaker. Mostly, not mostly, but sometimes you can find the breaker with the 2 brick or two interrupter per phase, usually on the high voltage circuit breaker. So on that condition, the maximum difference between 2 interrupter is 8 cycle, mean 20 divided 8. I think less than 2.3, yeah, no, 2.3 millisecond for the maximum difference between interrupter in one phase for the high voltage circuit breaker. So they can follow or read this standard IC 62271-100. Okay, Michael.
All right, thank you so much for the answer. We have another question here: how to position BD4 breaker to test timing?
How to position VD4 breaker to test timing? For test timing, I think not only for VD4. Actually, all MV breaker will be the same. You need to rake out first the breaker like this position. Just a moment. I think I have picture. Just a moment. I think this is regarding to the FD4 breaker. This one. If I'm not wrong, I think this is regarding to the FD4 breaker. You need to take out the breaker from the panel, and after that you need to connect this part. This part you need to arrange to arrange the position. Maybe put inside little bit and put this control terminal to the system. So I mean we still use the voltage and circuit from the system. Only need to take out the breaker little bit to possible connect the main contact to the main contact breaker. Yeah, normally like that. We need to take out first little bit and still using the circuit from the system, and then connect to the main contact.
Okay,
Yeah.
thank you, bro. Another question here: what should we do when the timing test is out of the standard?
Wait, okay. What should we do when the timing test is out standard? Actually, you need to discuss with the OEM manufacturer of the breaker. Usually, they do some adjustment on the mechanical part. So, but I know they can do some adjustment on the mechanical part of the breaker. So I recommend you to discuss with the circuit breaker manufacturer about it. Yeah.
Yeah, it could be very dangerous, sir. We want to avoid the single phasing. So if it's not synchronized, then you will have, some problem on the single phasing. One phase will carry more current than the other. So you need it is a must to have a synchronized poles. All right. So another question here: can we use VIDAR for medium voltage breaker?
Yes, of course. Actually, the main purpose of FIDAR is for the MV vacuum circuit breaker. We have maximum output up to 60 kV. So I think quite enough for testing MV breaker, because normally we test 2 times plus 1 and only 75% from that value. So yes. So the answer is yes. FIDAR can be used for the vacuum MV circuit breaker.
Yes, bro. This is to check the vacuum integrity, right?
Yes, correct.
Okay, so there is a question here. Sorry, it's not a question, sir. Where can we find the evaluation? Sir, when you close the webinar, there will be a pop-up screen, and you can see the form for the evaluation. Thank you so much, sir, for filling it out, and that will help us in improving our future webinars. Okay, bro. So I guess that's all the questions that we have for today. And at this point in time, we can conclude our webinar. And I would like to say thank you everyone for joining us today and hope to see you again next time. We still have a lot more until December, I guess. And yeah, please have a good day and stay safe. Thank you so much, Mehdi, for the presentation. And
Thank
so
you,
much.
everyone. Thank you, Michael and Grace. Bye-bye.
Bye-bye.
Thank you, Sumiti. Thank you, Michael. Thank you, everyone. Bye bye.